Welcome to our second lesson in Algebra 2. This lesson is going to be a review of graphs of lines. I know graphs of lines are covered in a lot of detail in Algebra 1, and I hope that a lot of this lesson does feel like review and it feels comfortable to you, but there are a couple of very key ideas that transfer outside of Algebra 1 into Algebra 2 that I want to make sure I hit very thoroughly and make sure we're all on the same page as much as possible. My camera is still not working, and I have not been able to figure out a way to turn off the little gray, or it's not really little, it's kind of like a big gray dot down at the bottom of the screen. And when I clicked on something a moment ago, it advanced my PowerPoint. I had to restart. So would like to not do that again. Great, so I want to start off with what is a graph? We do lots and lots of graphing in mathematics, but what is a graph? Why is this a piece of what we study? Why is it one of the tools that we use? Well, the definition for graph that I like to use is that the graph is the picture. Okay, we all like pictures. It's the picture of the points that make the equation true. Now, that might ring a little familiar to you because in the last lesson, we talked about how the solution to an equation is the value of the variables that make the equation true. So that idea of an equation being true is really important. And we tend to like pictures. If I want to describe something to you, I could describe it in words, which are valuable. And I could also choose to describe something to you using a picture. And so in math, we actually use both. We use words and we use pictures. We also use numbers, equations, and other ways of describing things. But the picture can have a real advantage to us, just like if you were building let's say you're building a piece of furniture, like a chair from IKEA or something, and you've got all these directions, but what really helps you out is a picture. Show me how these pieces fit together. So that's what a graph is. It's a picture of which points make an equation true. So in essence, a graph is a picture of the solutions. So instead of doing algebraic work to find solutions, sometimes we can kick it over to a picture. Now, there's a lot more nuance to it than that. But in essence, what we're doing is we're drawing a picture or constructing a picture of the solutions to an equation. So why is this an important concept for Algebra 2? Why is it worth it for us to take an entire lesson and back it up into Algebra 1 and reinforce this idea that a graph is the picture of the points that make the equation true? Why do we need that moving forward? Well, this is what all graphs are, not just some graphs. Okay, in algebra, I should specify, in algebra, this is what all graphs are. Like, so if you're in a data and or statistics class and you've got like a bar graph or something, that is a little different. But when we're talking about the XY plane, this is what all graphs are in algebra. And so what that allows you to do is it allows you to handle graphs even for functions and equations that you have not yet been taught. And I love it when I have a typo in that. I will go back and fix that before I present the lesson, but here, I'll just go in here and fix it. Okay, yep. That you have not been taught. B-E-E-N. So when you understand what a graph is and how it is generated, you will be able to handle graphs even for functions and equations that you have not yet been taught. And that allows you to step beyond the template or the procedures of a narrow concept and extend it and broaden it out. Because the truth is that we're going to try to cover as much ground in Algebra 2 as we can, but we might not be able to cover absolutely everything. And then you're going to move on to another math class. Well, when you understand these key ideas, it's going to make it easier to kind of fill in the gaps or the holes and stuff that we might miss. It's very important. So what does this actually look like? So we have a couple questions here. Is 4, 3 a solution to y equals 1/4 x plus 2? So when you're checking this, okay, you've got the x coordinate, which is 4. and you have the y coordinate, which is 3. And I'm going to go up to the upper right hand side there. Remember that when you have ordered pairs, the x coordinate is first and the y coordinate is second. You cannot switch that. You will be the only person in the world that does it, and you'll get everything wrong. Now, to check this, we're going to fall back on a skill from the last lesson, which is you plug the numbers in and then you check to see if the equation is true using your order of operations. It's called evaluating it. With this one, though, we're going to be plugging in two different numbers. We're going to be plugging in the x and the y. Before, we were just plugging in the x. So right underneath my equation, I am going to plug in 3 for the y, and then we have 1/4 times x, and we'll plug in the 4 for the x, plus 2. Every year, I will have some student ask about the fraction bar being tilted versus horizontal. Those are just two different ways of writing a fraction, and PowerPoint, when you type them in, it automatically converts that to the slash for it. And so that's 1/4, and the x is outside it. So I'm going to, it is not this, okay? Those are not the same things. So if you have the x on the outside of the fraction, that's not the same thing as the x being in the denominator. It is the same thing as the x being in the numerator, and maybe I'll be able to show you why. So now we want to evaluate this. So our order of operations, we have parentheses, exponents, then we kick over to multiplication and division. And so I'm going to do this multiplication. This is 1/4 times, and then if we want to multiply fractions, well, we would multiply straight across. I'm going to rewrite the 4 as 4/1. So I'll pause for a second, just make sure that you had a chance to think that through. And then I have the plus 2. When you multiply fractions, that is the easiest thing for us to do. You just multiply straight across the numerator and denominator. So I'll have 1 times 4 on the numerator, and then 4 times 1 in my denominator. So 1 times 4 is 4, 4 times 1 is 4. And now we'll do the division. I am about to run out of space there. So move it over here. 4 divided by 4 is 1. And then 1 plus 2 is 3. So we would end with the adding and subtraction. This is true, and so we would say yes. 4/3 is a solution to y equals 1/4 x plus 2. The other way you might see that question phrased is this way: is 4/3 on the line y equals 1/4 x plus 2. Okay, so that's the other way you could see that question given. Now, the next one is to drive home a point. And this is why it's important to understand this idea, not just copying a lot of steps that your teacher does. Because this function or equation, we'll use the word equation, it is a function too, but is not a family that we have talked about yet. This will come about halfway through the school year. We'll look at this particular kind of equation. But if you were asked the question now, is -1 2 a solution? A lot of students will say, well, I don't know how to deal with that. We haven't been taught that. I don't know. And they'll bubble in, say, C on a multiple choice test. Except you can answer this if you know what graphs are or what a solution is. So we've got x is equal to -1. We've got y is equal to 2. So I plug in the 2. I do -4 times x. X is -1 plus 3. And then we follow order of operations. -4 times -1 is +4. The square root of 4 is 2. And 2 plus 3 is 5. And so I get down to the end here, and it says 2 is equal to 5, and that is a false statement. And so my answer is no, it is not a solution, or also not on the graph of. So the point -1, 2 is on the coordinate plane, but it is not on the graph if you were to graph that. So I really want to emphasize why this is an important idea for Algebra 2, because it extends out. Now, in this lesson, we are going to focus primarily on lines and make sure that we are good to go with getting graphs of lines. And they're usually the most basic type of function that we deal with, and that will lay a good foundation for what we have in the future. Now, when I click this, there is going to be a text box that's going to pop up right in this area of the screen. So if you are taking notes, which you should be writing down at least one of the two examples here in your notebook, pause the video right now and just make sure you've got that copied down, because the next thing I'm going to do is erase it. All right, so we're going to erase that so that we have the space over here. It's the beauty of the video. Okay. So if a point is a solution, it means that that point will be on the graph of the function. So we know that the point 4, 3 will be on the graph of that line. We know that negative 1, 2 will not be on the graph of that other function. We don't know what that is yet. So this leads us to a foolproof way to graph, well, to graph anything. Many years ago, when I taught 7th grade Algebra 1, I had those kids graphing sine waves and exponentials, not because we studied sine waves and exponentials. We didn't. It was an Algebra 1 class. But I did really drive home that the way you generate the graph is you find the points that make them true. So suppose you need to sketch the graph of y equals 2x plus 4. One strategy is to build a table with enough points so you could see the general shape of the graph. Now you can do this on a calculator, okay? And so or you would do scratch work off to the side. So if you're doing this for me, I don't necessarily want to see every single time you're plugging this in. You might just like tuck it off to the side. So I'll do a little bit of the scratch work. So here we have some x values. So we have x is equal to -1. So you would plug in 2 times -1 plus 4. 2 times -1 is -2, and -2 plus 4 is +2. And so there you've got the point -1, 2. That means that -1, 2 makes the equation true, and it means that that point is on the graph. When you plug in a 0, okay, 2 times 0 is 0, and 0 plus 4 is 4, so the point 0, 4. We plug on in a 1, so we have 2 times 1 is 2, and 2 plus 4 is 6. And what you might notice is that if there is a pattern in your x's, that there is also a pattern in the y's. So on my x's, I'm going up by 1 each time. So I go from -1 to 0, and then 0 to 1. And then as I'm doing that on the y column, it went from 2 to 4 to 6. So if that pattern holds and I go up by 1 again on the x's, then I should go up by excuse me, 2 on the y's, which means I think that that should be an 8. So that would be 2 times 2 plus 4. 2 times 2 is 4, and 4 plus 4 is 8. And that confirms. And that's because when we're dealing with math and you're dealing with functions, there are patterns in the numbers, and a lot of times you can see that. Now, this last one actually goes out of order in the pattern. Okay, so I jumped back down to 0.5. One of the reasons I did this was because I wanted you to realize that you could use decimals in the table. So I wanted to make sure I had an example of that. And also to point out the establishment and breaking of the pattern. Okay, but we could still probably reason this out. Okay, so, I was waiting on the 3D printer to finish printing, and it's done, but I am going to finish this. So the 0.5 obviously goes out of order, but notice that 0.5 is halfway in between the 0 and the 1. All right, so 0, 0.51. Well, it would make sense if the y value was halfway between the 4 and the 6. Well, what's halfway between 4 and a 6? A 5. Now, let's see if that works. So if I plug in 0.5, half of 0.5 is 1, and 1 plus 4 is 5. And so the pattern holds. Now, I will point out that that is a pattern for lines when things are linear. It does not necessarily hold for other types of functions. What is safe to say is that if 0.5 is between 0 and 1, no, I don't even want to go that far. That would only be true if, you know what, I don't even want to open that can of worms. Okay. Now, a few notes about building a table. Sometimes the X values are provided. So in this case, I put in there a column of X's for you. Okay, so I provided some X values, but when they are not, you are free to pick any numbers you want. So you just pick some values for X and you find the Y that goes with those numbers. So if the X's are not provided for you, you just make up some X's, okay? Some values work better than others. So knowing which ones are best comes with time and practice, but there are no wrong values. Now, when we get to some other types of equations, you might pick values of X that actually don't have a Y to go with them. And that is also valuable information. And you'll learn very quickly with some practice, time and practice, which ones are going to do that as well. You can pick fractions and decimals, but we usually don't, and that's for obvious reasons. As soon as you start throwing fractions and decimals in there, you're making your arithmetic work unnecessarily complicated. There are no wrong values, so if you wanted to go pick really ugly decimals for every single one of your X's, you knock yourself out with that, but you usually don't. I just don't want to gloss over the fact that they are numbers that you could pick. And lastly, good values to consider are -1, 0, 1, and 2. Those are usually pretty reliable numbers to plug in. But there will be ones that, like, sometimes odd numbers don't work and even numbers do work. And so there are, different equations going to behave different ways, but you should always consider -1, 0, 1, and 2. And then it becomes like some students want to keep getting bigger, so they'll go to 3 and 4 and 5. You got to pay attention to what is happening with the numbers, because it might be better for you to go to, say, -2. So you might be trying to avoid the negatives, and then it ends up not being a great idea. All right. So let's see what this looks like when we graph them. Now I'm doing this with a mouse, so this should be fun. So remember, we just found a bunch of points that make the equation true. So I come over here to -1, +2. That means that point is on the graph of that line. Next one is 0, 4. So the X is 0, and we go up to 4. Now we have 1, 6. And again, this is that pattern that we were seeing in the numbers, that when the X's went up by 1, the Y's were going up by 2. And this is what that pattern looks like when you sketch the picture. That's why graphs can come in handy. When X is 2, Y is 8. And now this one, again, I really wanted to make sure that we were getting this. 0.5 is right in between the 0 and the 1. Do you need to estimate that? Probably. Is it okay to estimate? Usually. Graphs are not typically about being super, 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 super accurate all the time. They're about getting a picture. It's getting a sense of what the relationship is. So when X is 0.5, we're going to go up here to the 5. And what you should notice is that that point is in line with the rest of them, even though we did them out of order. And then what we would do is we would say, well, these are not the only points that we could have picked. Could I have picked a 3? Could I have picked a 4? What about a -10? Could I have picked a -10? Sure. And so what we'll do is we'll use those points to give us, that is horrible. Okay. This is not easy to do, just for the record, but I feel like I should be able to do better than that. There we go. Okay, and we put these arrows at either end. And what those arrows tell us is that, hey, you know what? The number of points we could pick, they keep going on forever and ever and ever. So while I used a collection of points to generate the graphs, those aren't the only points that are on the line. So for example, we've got, say, this point. This point is also on the line. I'm not entirely sure where that point is, but I could have picked it. I could pick that, and I could plug it into the equation, and it would make the equation true. It would be a solution. Okay, so this one is for you to try on your own. So pause the video, and in your notebooks, just do like a quick sketch. You can do your scratch work off to the side, or in on a calculator, that's fine. Just make sure that you can follow your work. Okay, now this one does not have any x values in there, so I'm going to just pick some x values. So I had mentioned that, say, -1, 0, 1 works. Let's do 2, and then we'll pick another one. We're going to reflect on it a little bit. Now, if you're looking at your work and you picked other numbers, that's totally fine. Okay, it's totally fine for you to pick other numbers. All right, so starting off with -1 minus 2y equals 4. We're going to add 1 to both sides. So we'll get -2y is equal to 5, and then divide by -2. And then my calculator will tell me that that is -2.5. Now, I am not particularly happy with that. Okay, that's maybe not what I was hoping in my heart of hearts was going to happen. Let's do the next one though. We'll do 0 minus 2y equals 4. So that's -2y equals 4. Divide both sides by -2. And we get y is equal to -2. Now I like that one much better. So 0, -2, I feel pretty good about. Okay. To erase some of this work. All right. Next point is a 1. So we'll do 1 minus 2y equals 4. We're going to subtract that one. So we'll get -2y is equal to 3. Divide both sides by -2. And my calculator will tell me that is -1.5. So I'm not really happy with that one. But you should notice a pattern. Okay, so it went from -2.5 to -2 to -1.5. So if this pattern continues, when I try x is equal to 2, okay, I might get something nicer. So we subtract the 2, -2y is equal to 2, divide by -2, and I get y is equal to -1. Okay, now when we do this, what you might be noticing is that some of these numbers come out nicely and some of them aren't. So I have like kind of a yucky number followed by a nice number, followed by a yucky number, followed by a nice number. If that pattern holds true, then the next number would be a yucky number. So what I'm going to do is, instead of picking a 3, I'm going to jump over the 3. Okay, I'm going to jump over a 3 and I'm going to go to 4, because if I've got yucky number, nice number, yucky number, nice number. So this would be 4 minus 2y equals 4. We're going to subtract 4. We get -2y is equal to 0. I love 0. 0 is my favorite number. You're going to hear that so much this year. 0 divided by -2 is 0. If you question that, go grab your calculator and your calculator will tell you that is the case. Now, all your scratch work to do this, I don't need to see all that scratch work, but maybe just put it off to the side. So now let's go ahead and graph this. So -1, and then it's down -1 to 2.5. So right about there. You can see on the coordinate plane. 0, -2. So that's right there. 1, -1.5. That's going to put me, oh, wait, I didn't quite do that right. I can do this? Promise I can. 1, there we go, -1.5. Now you'll notice that there is a pattern there. 2 comes down to -1. And then we decided we were going to jump over the 3, saying, I don't think that one's going to come out very well. And then the next point would be 4, 0, which seems a lot nicer. And then we would remember, hey, we did pick those points, but we could have picked other points. So here's how you know how you did. You do not have to have the same table as me. You do not have to have the same dots as me, but you do need to have the same line as me. So I want you to notice that to gauge whether or not you did this correctly. There are an infinite number of different tables that you could have, and there's infinite numbers of points on this line that you could have used, but the line needs to be the same. So as long as your line is in the same spot, you did this just fine. All right, so a reflection question. Did some numbers work better than others? Which ones, and why do you think that was? So in class, I'm going to give you some time to kind of reflect on this, like which numbers seem to work. 0 worked, 2 worked, 4 worked. If we did the same pattern and we jump over the 5 and we get to a 6, 6 would work, 8 would work. And then I want you to think about the algebra work. There was a step in the algebra where we had to divide by -2. And so the numbers that work nicely are the ones that divide by 2, which would be your even numbers. Now, does that mean odd numbers don't work? No, not at all. The odd numbers still work. They're just not as nice. That's the kind of thing that you will get better at with the practice. Remember, there are no wrong numbers to pick. There are just sometimes better numbers. Now, for this next part, I am going to ask you to go to Desmos.com, and we're going to explore how to graph there. Right. Desmos is a free graphing utility available online and via an app, so you can download the app onto your phone. Their goal is to provide equal access to high-level graphing technology. Graphing calculators can run into quite a bit of money. If you take pre-calculus, you will need to get yourself a graphing calculator. Desmos is free, okay? And so there's no cost. So this is your chance to learn how to use a graphing utility before you decide to pay the money to get your own. I do want you to use the online version though, not the app version. So the app version, if you want to use that on your homework, or you want to use it if you're doing homework in the car or a place where you don't have your laptop, that's fine. But in class, I want you to be using the keyboard, because the keyboard is what you will have access to on your exams. Hence the next point. Desmos is the embedded test calculator for several high stakes tests. So learning how to use it is worth your time. Desmos is a calculator that you will see in places when you click the little calculator icon. Desmos is what's going to pop up. And so learning how to use it is going to be worth your time. Even if you're not planning to do math after you take this class, which I hope that you do, but if you're not. And so I want you to use the keyboard version of it, because that's what's available to you, not the app version. Some things about them are the same, but some things are different. In this class, you are expected to use Desmos instead of Mathway, computer apps, or other online platforms. So I am aware that some students really, really like the Mathway calculator. No, use Desmos. Why? Because that's the one that you can use on your high stakes tests. Okay, that's the one we want to practice on. So when you're taking your high stakes test and you click the little calculator icon, Mathway is not what is popping up. Desmos is going to be what pops up. Be sure to follow along in class when we do Desmos examples. In my time using Desmos in my classroom, a lot of students just watch. Don't just watch. Take out your laptop and follow along with me. Type in the same things that I'm typing in. It's not hard to type them in. This is the best way to prepare for using the calculator when it counts. And we got close to our EOC this year, and I did some calculator exercises and asked students, well, what can you do to get better at the calculator? And they said, study. Not really study. What you need is to practice. It's just not something that you study. It's just a skill. So follow along in class when we do it. All right, so this is when my window is about to get jacked up. So what I want to look at in this one is graphing a line, finding key points, and tracing the line. So when I click on this, it will pop this up, and hopefully I won't mess it up. But to graph a line on Desmos, well, first let's like do some plotting of the points. So thinking about the one that we just did, I know it went through the point 4, 0. So literally, if you type that in as an ordered pair, you will see this awesome little dot appear over here. You can also label that dot. So if I wanted to label that dot X intercept, it'll do that. So you can actually generate some pretty nice looking graphs with that. Okay, I will turn that off for now. You can plot multiple points by placing a comma, and then, oh gosh, what was one of our other points? 2, -1. Okay, and it will plot both of those, and you can plot as many points as you want that way. You can also, on Desmos, plot points using a table. And so if I see this little plus sign, one of the things that I can add is a table. And that will allow me to plot the points there. So I can do X is 4, Y is 0, and X was 2, Y is -1, and you can go down that way. Now, you'll notice a couple of things. We will deal with this in a future lesson, but notice the subscripts of 1 there. What that means is table 1. If I were to click down here and add a table, you'll notice it says X2, Y2. That just means table 2, okay? So that's what that little 1 means. So table 1. And I don't remember what 0 was. 0 was -2, I think, right? 0 when X is 0. Okay. So we got some points there, and then we had the yucky ones. So we had 1, -1.5, and -1 was -2.5. Okay, so you've got your collection of points. This is the same collection that we had. And we can graph the line. So it was X minus 2Y is equal to 4. And you'll notice that that line goes through those points. Now I am going to delete my table. Okay. And so now all I have there is the graph. So you can like pause, rewind. Again, make sure that you're doing what I'm doing. You're not just watching me. When I click in this window, you'll notice that Desmos puts dots on the graph, and you want to be aware of what Desmos does. So I can click on those dots, and the coordinates for those points will remain on the screen. It makes the dot like a nice bold color. Desmos tries to read your mind, and it tries to, think about, well, what are the important things about this that this person might want to know? And yeah, so they'll put the dots there. Now, sometimes the dots are the points that you want. Sometimes they're not what you want, so you don't just want to write down dots. But it is kind of nice. Now, if I put my mouse on the line and I click it, notice that a point appears. And what that point is doing is it's tracing as I'm moving up and down. Okay, let me turn these off because they're kind of getting in the way. Okay. It's giving me all kinds of ordered pairs that work. So remember that we found the point 2, -1. There it is. Point 2, -1 is one of the points on this this line. There's let's see if we can find 1.5. There we go. Oh no, it wasn't 1.5. It was 1. Yeah, 1. There we go. 1, -1.5. So that was one of the other points that we found on this line. As I am tracing up and down, it's giving me all of the decimals. Remember, the graph of a line is the points that make the equation true. And so it's so much more than just whatever points are on your table. Now, just as a heads up, if you're watching this, and I should have said this at the beginning of the slide, every once in a while, my students will tell me that the Desmos doesn't show what it's supposed to show. It just doesn't show stuff. And so if that's the case, just drop me a message and let me know. I can record this as a separate video, just like a little demo, a little like 2 or 3 minute demo if this did not show. Okay. All right, so for your classwork, this is build the table to sketch the graph. And that, sorry, the bottom that got cut off a little bit. Y is equal to the square root of x plus 2. Now, we have not studied what that's going to look like. I'll give you a hint. It's not a line. So go ahead, pause the video, and yeah, go ahead and pause the video, fill out the table, and get some points, and we'll review it together. Okay, so for me doing this, I'm going to pick x is equal to 0. I'm going to pick x is equal to 4. I'm going to pick x is equal to 9. I'll go ahead and pick, I like x is equal to 1. And then I'm going to pick x is equal to -1, right? Because my teacher told me that that was a good thing to pick. All right, now y is equal to the square root of 0 plus 2. Well, the square root of 0 is 0. And 0 plus 2 is 2. So the point 0, 2. So that's going to be right there. Now we'll do the square root of 4. Well, what is the square root of 4? That is 2. And 2 plus 2 is 4. So we have the point 4, 4. If I could find my, it's way up there. Okay. So 4, 4. My next point that I picked was 9. So we'll do the square root of 9 plus 2. Square root of 9 is 3, and 3 plus 2 is 5. So coming over here to x is equal to 9, we'll come up to 5. Not a line, okay? If it was a line, let me see if I can turn on the pointer. If it were a line, it would go like this, and it didn't. It kind of curved around and went there. All right, let's erase this just to make room for my scratch work. Okay. And we're going to do y is equal to the square root of 1 plus 2. Square root of 1 is 1, and 1 plus 2 is 3. And so the point 1, 3. There it is. Okay. All right. And then my last one, y is equal to the square root of -1 plus 2. That is going to error on you. And so I'm going to just say not applicable. That's what NA usually says, like means not applicable. So what that means is that there actually is no y value. It means that over here, where x is equal to -1, there's no point there. Like that graph doesn't actually exist there. Now, if you're wondering, what does this actually look like? Well, you would start here at your 2, and you're going to draw the best shape that you can, and it goes on from there. So it looks sort of like a line that is kind of curving and maybe becoming flatter. So it starts out, let me see if I can grab like my highlighter. So it starts out pretty steep, like going up in that direction, and then it gets less steep, and then it gets even less steep as you're like moving. So it starts out like a pretty steep line. So hopefully that helps you see it. Now, will we cover this type of graph? Yes. Will we cover it like right now? No. This is an exercise in practicing the points, but I am hoping that it helps you see why this skill is useful. Okay, so here's your homework. Last couple questions. Is the point 1, -4 on the graph of? Okay, show your work. In other words, I want to see that you plugged it in and that you're getting either a true statement or a false statement. So that would be for number 1 and number 2. You could also have the question phrase, is the point a solution to? Okay, you'll notice that question 2 is something we haven't done before. Questions 3, 4, and 5 are all build a table and then construct the graph. I need to see the table and the points that you picked, as well as the graph that you're doing. I do not need to see all of your scratch work. You are welcome to use a calculator for that. Now, questions 6, 7, and 8. 6 is graph y equals 4x minus 6 on Desmos and trace along the line. Name one point on the line that uses decimal values for x and y. Okay, so something that's not a nice friendly number, but it's kind of messy. For number 7, I want you to change the -6 to other numbers. Be sure to pick smaller and larger numbers, as well as negatives and decimals or fractions. So basically do like y equals 4x minus 8, y equals 4x minus 2, y equals 4x plus 2. You can do a 0, okay? And the question I want you to answer is, what effect does this have on the graph? So just pick a bunch of numbers, change them out. You just, on Desmos, you're going to hit delete and put a different number in there until you feel like you can explain what that number does. For question 8, you're going to just replace the -6. Okay, so just put the -6 back. Now I want you to change the 4 to other numbers. Be sure to pick smaller numbers and larger numbers, as well as negatives and decimals or fractions. Check 0 also. What effect does this have on the graph? So as you're messing with that number in front of the X, I just want you to mess with it long enough to figure out, how does that number influence the graph? And then question 9, of the problems that you answered, which would you like to review as a class? Do not write down problems that you skipped. Okay, so homework review is about clearing up questions and concerns you have as you're doing your homework. It is not about Miss Taylor doing your homework for you. All right, so